Hi, good morning. My name is Dr. Jay. I've started this new YouTube video series on non-destructive testing, and today I'll talk about visual examination. But before I go into the visual examination, I would first like to state the purpose of this video series, that it is only for the education purpose and to facilitate easy and comfortable learning. Also, there is an attempt which has been made so that each video is less than 20 minutes and each video is dedicated to only one specific non-destructive testing method. So the basic idea here is to discuss the basics of different non-destructive testing methods in the most simplest language possible. Of course, the NDT field is extremely wide, and the contents in this video is limited to my understanding on the subject. It will provide a basic starting point or platform to students and professionals around the world to perform their experiments. Now, let's talk about visual inspection. So, visual and inspection. It means inspection by visual means. So what essentially we do here is the examiner observes a component with the help of the naked eye, and he or she tries to evaluate whether there are presence of any surface discontinuities. It is usually the first step in the non-destructive evaluation so that we can spot the defect externally without going in depth. Some NDT engineers or specialists think that it's not essentially an NDT method, but it's only the first step towards the process. So first, when a component comes to them, they first try to see with the help of naked eye whether they could see surface discontinuities and whether they can inspect that the component is good to continue its service, it needs a certain kind of repair, or it has to be completely rejected. The other motive behind visual inspection is to study if a component is failed, then what is the reason behind it, why the component is actually failing, or what were the situations which led to the failure of the component, and this we may be able to predict with the help of visual inspection if done correctly. Now let's talk about the applications. Why we need to do visual inspection? So visual inspection, it helps us in detecting variety of surface flaws and discontinuities. These surface flaws, discontinuities may be because of corrosion, because of contamination, because of inadequate surface finish, or because of improper joints, or it can be because of any other reason. What exactly is the reason? That comes with practice and experience. Now, what if defects are not visible to naked eye, or visibility of the surface of component needs to be enhanced? What can we do in that scenario? So here we take the help of visual aids. Visual aids are nothing but some things which can help us see the surface discontinuity in a more clearer manner. So the first visual aid is a microscope. If your component is small, then you can see the surface discontinuities with the help of microscope, and you will be able to figure out where the defects are actually present. The another kind of visual aids which non-destructive engineers or non-destructive scientists use is magnifying glass to see the level of surface discontinuities, if the surface discontinuities can be visible with the help of naked eye, right? So if we are not able to see the discontinuity with the help of naked eye, then we can use the magnifying glass so that we can see the crack or the discontinuity in a more clearer manner. Or we can enhance the visibility of the component so that we can predict the future of the component, whether it is good for service, whether it needs repair, or it has to be completely rejected. Now, the third question which comes to the mind is, what if we cannot see the component with the help of naked eye? The visual aids are also not enough. So what kind of situations are there in which we cannot see with the help of naked eye, or we cannot even use visual aids? What to do then? So, for example, if you have a component whose physical access to area is very limited or not possible, and that is why you are not able to see the surface. For example, you have to inspect the inner surface of the bolt hole. Now, there is no way you can access it physically, and there is no way you can see it. So in that case, what we do is we use equipment called borescopes. So borescopes are nothing but a tube whose diameter will depend on the diameter of part or the area to be inspected. The tube diameter is usually 4 to 70 mm. Again, in borescope, there are two different types of borescopes. One is rigid borescope and one is flexible borescope. In rigid borescope also, there are two kinds of borescope, which is lamp at distal end and light guide bundle in the shaft. So let's first talk about rigid borescopes. Rigid borescopes usually we use where there is a straight line path between observer and the area to be observed. Okay, because we do not have much flexibility over here. The lengths of rigid borescopes vary from 0.15 to 30 mm. The diameters vary from 0.9 to 70 mm. But the magnification we can power up to 50x depending on what glasses we are using. Now let's see how the rigid borescope actually looks like. So rigid borescope actually looks something like this, where you have a rigid borescope with lamp for illumination. So basic idea is that we want this instrument to go inside the component which we cannot access, and also when it goes inside it should have certain light source so that we can have the visibility. Okay, so this end is called distal end, and this end is the end where eyepiece is present. So what happens over here in distal end? This end actually goes inside the area to be examined, and this end has an incandescent lamp, and what this incandescent lamp will do, it will illuminate the area under examination, and there will be enhancement in the visibility. And with the help of this relay lens and with the help of the eyepiece lens, we will be able to see the area which the distal end has been into. So by this manner, we can access the parts which we cannot access by any physical means, and at the same time we can view it and we can figure out whether there is any discontinuity present or not. But this is the first type of rigid borescope. So it is completely rigid, it cannot be moved or bent. Now, what if we want to increase the field of view for rigid borescope, or the field of view for rigid borescopes need to be broadened? Can we broaden the field of view for rigid borescope? So if we want to increase the field of view for rigid borescope, we use different kind of borescopes with light guide bundle. Light guide bundle is nothing but it is made from optical fibers that helps in the conduction of light from an external source. So basically, this has a rotating tube which can give you an orbital scan. Now, this is the figure or the illustration of the rigid borescope with light guide bundle. Okay, you can see there is a shaft over here which can be rotated, and with this orbital scan we can increase the field of view of the component, and we can see more areas with only one instrument. Initially, with the help of the first type of microscope, the access was limited, but here the field of view is enhanced because we have the rotating shaft. And you can see here there is a light guide bundle. Light guide bundle is nothing but it helps you to carry the light to the area being examined. So there is a light source over here, there may be a light source over here, and from this light source, this light guide bundle will take the light to the area being examined. And that is the importance of light guide, that it will help you with enhancing the visibility. Now, what if more flexibility and broader coverage is required? What can we do in that area? Or what can we do when we want more flexibility and broader coverage? So we use something called flexible borescopes. In these borescopes, we have image guide, which is over here. This image guide helps you to form the image. So we have different lens system which will help us to form images, and we have a light guide to carry the light to the area being examined. So there is a light guide, there is an image guide, and there is a light guide which helps you to see the component part which was not initially visible with the help of visual aids or with the help of the naked eye. Now we can see those areas, and this flexible borescopes overcomes the limitations with the rigid borescopes, and it will give you a broader range or a broader area or a broader perspective to see things and examine whether there are any flaws or any surface discontinuities present in a material or not. And subsequently, the NDE engineers or the NDE scientists can predict the future of the component. These are my references. Please feel free to visit and learn more about the technique if you want to. And in the next video, I'll be talking on dye penetrant testing. It is a brilliant type of non-destructive testing method, and I will be talking on it in the next YouTube video. Thank you for your time, and I'll see you in the next video.